Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I'm going to talk about torsion and torque vectors, okay, which is a part of the topic 3.12 torsion in chapter 3 load and stress analysis from Shikli Mechanical Engineering Design textbook, okay. So in the textbook, there is a figure 3.21 here, which depicted a cylindrical rod that you do the torsion of it. Okay, you do the torsion on the big on the cylindrical rod. Okay, what is a torsion? Torsion and torque in mechanical parts. Torsion occurs when a torque acts along the axis of part, causing it to twist. The torque vector aligns with the axis with the rotation visualized by the right hand rule. Okay, so you see your car, you see your motorcycle, the wheels that rotate, everything that rotate, they will the shaft that related to the rotation, then we have the torsion of it, and then we have the torque. Okay, torque equals to F times the radius. T equals to Fr. Torque equals to force times the radius of the thing. Okay, so it measures the right hand rule. Okay, you see your hand, you see your right hand. Okay, right hand rule is in determining the torque direction, where the curve of the figures follow the rotation, and the time point is the torque direction. Okay, so it is a standard. People want to make it a standard. Apply, for example, for screwdriver and the screw. Twisting a screwdriver applies torque to a screw, which follow the direction of the applied force along the twist axis. So when you twist the screwdriver, it follows the right hand rules. Uh, so you can tighten it, or you can untighten it. It always follow the right hand rule to become the standard lah. Most of things lah. Okay. So angle of twist and stress round in round bars. Okay, formula for angle of twist in the solid round bar. The angle of twist theta is calculated by theta equals to Ti over GJ, where T is the torque, L is the length, G is the rigidity, and J is the polar moment of inertia. Shear stress tau increase with the distance from the axis be given by tau tau equals to TR over J. This is critical in materials resisting high torsion, because if you twist something, something is twisted over its limit, it will become buckling, it will become damaged. Okay. uh, Engineers use this equation with design car shaft that can withstand high torque with minimal twist and stress deformation. Okay, you see your car always moving, it has twisting. Okay, the shaft, okay, they have the high torque. So engineers calculate everything so that the shaft do not become damaged. Okay. Shear stress in hollow and non-circular section. Formula for hollow round section. Shear stress the calculation in a hollow section use J equals to pi over 32. So this is the equation accounting both inner and outer diameter. Okay, because hollow section, they have inner and outer diameter. Okay, you can see where your pipe, you can see your pipe, PVC pipe, or pipe that for the water pipe, it has the hollow section for the water to move. Okay. So non-circular shear distribution in non-circular section like rectangles. Shear stress peaks midway along the long side and drops to zero at the corners. Okay. So example for hollow bicycle shaft, hollow section in bicycle optimize weight and strength, applying this calculation for durable yet lightweight design. Okay. So you may think that solid bar is strong. Okay, yes, it is strong, but the with the middle one, if you remove the middle one, it is strong. It is the same strong as the if solid bar. This is the principle of the hollow section lah. Because solid round bar, solid cylindrical bar is heavy. If you remove the hollow part, okay, remove the inner part, it still function as normal. Okay, and it is lighter. So this is the advantage of it lah. Okay, so torque and power relationship in rotating shaft. Power torque relationship. Okay, in rotating shaft, power H and torque T relate to H equals to T times V, where V is its angular velocity, establishing torque requirements. Okay. calculation in SI unit using T equals to 9.55 H over N. When if N as RPM, revolution per minute, engineers can determine the necessary torque to meet power demands. Okay. Application in, for example, application in wind turbine shaft. Wind turbine shaft design relies on torque calculation to optimize energy transfer and meet power requirements. Okay, this is the thing. Uh, Talking about torque meaning that higher torque, you have to pay higher electricity bills. You have to more fuel consumption, more money. Okay, so we have to use it wisely lah, because it at the cost will add the cost to our production cost. Okay, so that's the video right now. Inshallah, we meet in the next video. Thank you very much.